Hi there, my name is Josh, and game design is my hobby. On screen right now is an effect I made using shaders and Unity. It is one of many projects I have worked on in my journey to increase my programming skills. Today, I would like to invite you on that journey with me. Minecraft, a game with an infinite world, infinite possibilities, and infinite frames. That is, if you're using Optifine. Today, we're going to start recreating it in Unity, and striving to make it better every step of the way in every way. So, I started by creating a project naturally named Bad Minecraft Clone in Unity. But after creating the project, this happened. But when we start later, and everything seems to be working just fine. Now, to start, we need to figure out how we're going to generate the world. To generate the height, I'll be using Perlin Noise. Perlin Noise allows us to input an x and y coordinate and get out a value that ranges from 0 to 1. We can then multiply that value by a number that determines the steepness and height of our terrain. We can then use this method for every single block in the world to generate all the heights. Below all these heights, we want to fill in all the blocks, and that will give us the entirety of our naturally generated world, at least for now. There is a problem though. There is no feasible way we can generate an infinite number of blocks for an infinite world. So what I'm going to do, and what Minecraft did, is split the world up into a bunch of chunks that are 16 by 16 blocks in size and only generate the ones that are around the player. To do this, I will start by creating a chunk class that contains a list of blocks. After setting all the blocks inside each chunk, we can then take the ID of the block and use it to draw the actual block in the game. There is a lot we need to do to actually draw the blocks, so let's just start out by only drawing the top face of some blocks. Oh no, that's not quite right. Let's try that again. One quick fix later, and everything seems to be generating correctly. But to generate blocks for real, we have to take each block and check around it to see if there are any blocks there. If there aren't, then we generate a block face there. Now, let's implement that. Okay, so that's the exact opposite of what we want, so hopefully we can just flip around the conditions and... Okay, that's a lot closer to what we want, but some of the block faces are still generating on the wrong sides. So, let's fix that. There we go, everything's perfect. Wait, no, not actually. So, Unity can only generate the faces that are facing towards you. So, in certain situations, we need to flip those faces. So, with a little trial and error, everything is now working just fine. And with that done, I moved on to creating a grass texture in Photoshop. I threw something together pretty quickly, but after dragging it onto the object in Unity, I realized we forgot something. You see, right now, we're not generating UVs for the object. UVs are essentially a set of numbers that tell the block where to take its texture from. Anyways, one easy implementation later, and now the textures are rendering on the blocks. But on further inspection, textures aren't rendering correctly. You see, all these red arrows should be pointing right, but not all of them are. So one quick fix later, and everything's working correctly now. I then opened up Blender and started working on a player character. The player was pretty easy to design, especially because he's just made out of a bunch of blocks. I then downloaded the Steve skin. I created an entirely original Bob skin. You can tell because he has green eyes. I then applied that to the object in Blender, and after dragging it into Unity, everything appears to be working just fine. I then gave him a top hat because, like I said, this game will be better than Minecraft in every way once it's done. I then began work on a player controller script. And after finishing that, we can now walk, look around, and even jump. After tweaking the values a little bit, we no longer jump 1,000 feet in the air, and everything is feeling a lot better to control. I then made a block object. This object stores all the values pertaining to how the block is drawn and how it functions. We'll be using this for every block in the game. I then created a texture atlas which will essentially store all our textures for the entire game. I started with only having the grass block, and using that block script I talked about before, we were able to make all the grass blocks draw with textures on the sides as well. I then moved on to generating multiple chunks, which as you can see, went off flawlessly and definitely didn't result in hours of coding. Anyways, after a little work, that all seems to be fixed. But there are still some issues, like how faces don't generate on chunk borders. We can fix this though by feeding each chunk its surrounding chunks, so that way if there are blocks on the border, it knows when to generate faces. So I implemented that, and we now have an infinite world we can explore. But what's the point of an infinite world if we can't destroy it? It's time to introduce block breaking. To do this, we first need to know what block the player is looking at. We can find this by taking the player's viewpoint and raycasting out from it. We can then take that point and the face the raycast hits, and move from the point in the opposite direction of the face. This will give us a point inside the block that we can round down to get the actual world position of the block. We can then take that block and break it, and then reload the chunk to generate all the faces. But when a chunk is on a chunk border, we need to take both the chunk it's in and the chunk on its border and reload them both so the faces generate correctly. Let's start. So with a little work, I was able to get block breaking to work. But unfortunately, we suffered a casualty along the way. You see, while I was testing out block breaking, I tweaked the movement a bit, and quickly realized that the camera was clipping in with the player. So, unfortunately, we have to make the player cast shadows exclusively. I then realized another flaw in the game. Unity can only handle around 60,000 vertices, which may sound like a lot, but it could pose a potential problem in the future, especially considering each face has 4 vertices, and each freestanding block has 6 faces, meaning each freestanding block would have 24 vertices. To fix this, I'm going to take each chunk and split it into 4 meshes vertically. We can then hold 4 times the amount of vertices we could otherwise. As you can see, it took a little bit to implement, but eventually I got it all working, and now we won't run into that pesky problem of having too many vertices in a mesh. I finally moved on to adding a flower block to the game to add a little touch of color. We want to disperse this sparingly, unlike what happened right here. So using our friend Perlin Noise, I was able to get a more random and even distribution of the flowers. But the flowers shouldn't just be a texture on a block, they should be a cross shape, so I worked on adding that. We also don't want the flowers to collide with the player, otherwise we have weird collision behaviors like this, and it just feels wrong to collide with flowers. So, I removed the colliders, but doing so made it so we can't break the block anymore. To fix this, I made the flowers part of a separate collider that doesn't collide with the player, but can still be hit by the raycast. Finally, I finished the cross shape of the flower. And with that, we have now finished a significant portion of the game. Next time, what I want to do is implement block placing, lighting, structure generation, and if there's time, an inventory system with blocks that drop on the ground when you break them. Thanks for watching, and please tell me using the various means below this video if you enjoyed the video, as well as what else you think I should add to this game. I'll see you in the next video.